Hello all, my name is Sharma. Today, I'll be presenting a survey on 3D object selection techniques for virtual environments by Ferran and Carlos. This paper was published in 2012 at Computer and Graphics. Virtual reality environments have become increasingly popular due to the availability of low-cost spatial input devices and motion tracking systems such as Glove. We will take a quick look at a fully immersive virtual environment. Let's go to the link. And here we see that the person is able to grab an object, move it, manipulate it, and also you can see he has pretty good control over the virtual world. He's able to rotate and move it in this virtual space. We can see that he's able to navigate in this environment. And using the controls, he is able to go closer to the wheel and manipulate it as well. So these are the broadly three tasks that are associated with VR. So object selection, object manipulation, and navigation. So we will be focusing on the techniques for the first fundamental task, that is object selection. There are several challenges in designing appropriate 3D interaction techniques for virtual environments. 3D interaction, as you can see, is more physically demanding. It requires higher dexterity. For example, selecting an object using a mouse pointer is far easier than grasping a 3D object using a glove in free space. Furthermore, humans encounter difficulties in understanding 3D spatial relationships, and they also experience difficulty in controlling multiple degrees of freedom simultaneously. So you may not be able to rotate and move together, is what I mean. And then, so a 3D object selection technique requires users to gesture in 3D space, for example, grabbing an object or pointing to something. There are two main 3D selection metaphors used here. A virtual hand, as you can see a hand in the left picture, and a virtual pointing. You see a red ray on the right side. So in the early days, virtual hand techniques were more popular as they mapped identically virtual tasks with the real tasks, which resulted in more natural interaction. However, ray casting selection is becoming more popular as they result in better selection effectiveness, as they allow users to select objects beyond their area of reach. They also require less physical movement. There are two human control models that are used to analyze these selection techniques. First one is Fitts law, that estimates the time required to acquire a target, which is related to its size W, how big it is, and A, the distance from the object. So farther the object, the time will be more. And that's the equation. And then in the second human control model, we have the optimized initial impulse model. So it has acquisition tasks which has two phases. In the first phase, which is called the ballistic phase, we have a fast but inaccurate movement towards the target. In the second phase, which is called the corrective phase, several slow movements are made until the target is acquired. So it's more like rushing to the location of the object if you're far away, and then trying to grab it, like trying to get as close enough so that you intersect with the object and then you grab it. Here in this equation, S is the standard deviation of the endpoint and D is the distance covered and T is the movement time. Sorry about that. Okay, so now we have the classification of 3D object selection techniques used in this survey. We have selection tool, then we have the control over the tool, the degrees of freedom. Then we have control display ratio, and we have motor and visual space relationship. Then we have disambiguation mechanism, and we also have selection trigger and feedback, but we do not discuss in this presentation. In the first one, we have selection tool. So selection tool is required to perform an intersection test or to find out if you are near the object or not. So if you're near the object and if you're intersecting with the object, then only you can select it. It is typically either a one-dimensional ray or a simple 3D shape like a cube, cone, or a sphere. We have several examples here in the table, and we see bubble cursor uses a sphere-like selection tool, and another one is aperture selection that uses a cone as a selection tool. And then we also have techniques that use hybrid approach. They combine the ray with the 3D cursor, like depth ray and lock ray. So now once we have chosen our selection tool, let's say a ray or a 3D cursor or a combination of both, we then focus on how do we have the control by each 3D given by each 3D selection technique. So we have a degree of freedom. A degree of freedom is a term used for movement, like how much can you move? Like, is it a two-dimensional, three-dimensional movement you have, and do you have rotation, orientation, such as yaw, pitch and roll? So the more degrees of freedom you have, the higher will be the expressiveness, but it will be difficult also to control. So in this case, we have the degrees of freedom coming from the origin of the ray, either its orientation or position. As you can see, either it's a theta phi angle or an xyz coordinate. Similarly, the orientation or position of the dominant hand. Dominant hand is what you use as the glove for the glove. So you can have the xyz location of that or the angles. For example, in this case, the smart ray technique requires user to point to the desired target from several directions. So that can be from your dominant hand and from your ray or from your eyes, the view. And then we have the control display or the CD ratio that determines how translations and rotations of the input device are transferred to the selection tool in the virtual space. For example, let's say you move the mouse 1 centimeter, that will cause the cursor to move 1 centimeter too. So there are two types of selection techniques, isomorphic and anisomorphic. In isomorphic raycasting, the CD ratio stays constant. So if you move 1 meter in the physical space, you move 1 meter in your virtual space. But in an anisomorphic raycasting technique, such as in GOVA technique, the CD ratio is dynamic. So you can move only a centimeter, but you actually move a meter in the virtual space. This is good for selecting distant objects that are far off by just stretching your virtual arm, which you cannot do in your physical arm, obviously. And then we have the motor and visual space relationship, which so motor space and visual space is what you see and what all you can see. Um, the, they can be coupled like a virtual hand technique. So your motor visual space is exactly as your motor space. So absolute pointing can be accomplished, or they can be decoupled, such as go-go technique, where there is a constant offset. A perfect example of this is where, let's say, you have to aim the ray up high. You need to raise your hand for a long period of time up high in order to get that angle right. So in Google technique, you can have constant offset. So you don't have to raise your hand that high. You just move a little bit up, and that would not cause that much of fatigue. Whereas in virtual hand technique, it would have been you would have to aim high for a long period of time, and that would cause fatigue. And also there is clutching. Technique which allows users to determine the transformation between both spaces. So how do you want it? You choose it like that. And in this diagram, there's a top picture and then there is a bottom one. In the top one, you can see that the user can access only the objects seen in front of him that is his control space. Whereas in the bottom case, using array, the user is able to select objects outside his motor space, more into his control space. So that is because the bigger ball B is visible using two rays, even though there is a smaller sphere B in front of it. So you can still see the bigger sphere B, which is farther off, but that's only in the case of when you have isomorphic mapping. Then we have disambiguation mechanisms. So when we use volumetric tools, we are more prone to indicate more than one object at once, which can cause ambiguity. So you're pointing at something, but you're actually picking up many objects. So there is an ambiguity. So we have disambiguation mechanisms to fix that. In the manual approach, the user has to decide among the indicated targets which target is the desired one. For example, in the squad technique, the user performs simple selections through quad menu user surface. So basically there are like 4 groups, and you keep selecting the group which has your object until you reach the only one object, and that is the object you selected. So it's a very manual approach, but it's very accurate. And then we have a second group, which is the heuristic, which guesses which object the user is willing to select. So there is a ranking that is done according to the heuristic, and the highest ranked object is selected. We also use probabilistic pointing based algorithms here. And then finally we have behavioral approaches that are used to take into account users' actions prior to selection confirmation. So basically what happens here is that as the user is navigating in the environment, the process here keeps gathering statistical information and keeps the ranking updated. So it's not a static thing just before the object selection has to be made. So that is the behavioral approach, which is used by techniques like intent select and sense shapes in this particular case. And then we have evaluation technique of all these techniques we have discussed so far. So we have focused on the classification mainly, and Based on the classification, we can make a choice of what technique we want. So if we are so based on selection tool, if suppose you want simplicity and it's a simple model, then you can have 3D cursors such as we've discussed cones, cubes, or spheres, simple shapes, so that the intersection test is fast. And or if there's a complex environment and there are many objects including other objects, then you can use rays using flexible pointing, so you will have an advantage in that scenario. And then we have tool control degrees of freedom. Basically, in classic ray casting, some degrees of freedom are more relevant than others. For example, if you make the ray, the origin of the ray constant, then you can just manipulate using the orientation, just the 2 degrees of freedom of orientation. So using two virtual rays, whereas if you use two virtual rays, you can generate up to 10 degrees of freedom. So that's an advantage of using two virtual rays, and the intersection of these two rays would tell which object you've selected. And then you have control display ratio, we discussed. So if you have constant CD ratio, there is more accuracy. But with dynamic ratio, you can select distant objects, right, with the stretching the virtual arm, but it comes at the cost of precision. Then we have disambiguation mechanisms, and we discussed manual approach, which gives maximum flexibility, but the cognitive load increases on the user. So user has to pick out of the given options which object has to be selected. Whereas in behavioral approach, since the computer is guessing which object is to be selected, it's very useful in selecting moving targets, but it's not completely accurate. Finally, in motor and visual space relationship, we have coupling, which gives absolute pointing, right? So you have to raise your hand up to point, but it increases fatigue levels. So you have to raise exactly the way, like to match the motor and the visual space. But in case of offset or clutching, that decreases fatigue levels if you have an offset, but it may result in performance loss. So that's about it about the 3D object selection techniques. Any questions?